Good morning, guys. Let's get started while the others joins. Sorry, guys, I was not feeling well and I could not take the class on Friday. So I was suffering from cough and fever. So sorry about that. I hope you are able to hear me clearly. Yeah, I see Bharati is traveling, so will not be able to respond. So Akshay and Raj, I'll be depending on you.
Yes, sir.
Okay. Yeah, thank you. So in the last class, we discussed about the in order. What is a tree and how can I write in order? And that too recursive programming. So did you guys get a chance to pre-order and post-order? Or shall we write? I think that is the one homework I have given, right? Yeah. For this tree, I have asked you to pre-order, post-order. So did anyone get a chance or shall we write? I see one response. Yeah. I see one person has written. Yeah, it's good. Yeah. Whoever has written, thanks for that. Yeah. So shall we write quickly? Shall I write pre-order or post-order?
Yes, sir.
Which one you want me to write?
Post.
Okay. Okay, post. Okay, let's write post. And can you guys do pre today? Yeah. So let us think about let's go to the program. Yeah. So we have, post order is already written. Now let us look at the tree is this one. Let me maximize it. Yeah. For this tree, if I have to write a post order, what does the post order is telling you? First go towards left, towards right. And once this is breaking, then you have to write data. Okay. Now let us write this. Let me copy this. Yeah. Yeah. I hope you guys are able to see both now, both the screens.
Yes, sir.
Yeah. Let us write first. If where should I start the logic?
Root.
What is the root in this scenario?
50.
50 not equal to null, correct? If it is not equal to null, I have to go inside, correct? Now, inside, what should I write? I have to write 50 not equal null post order. Can I say 50 dot left and 50 dot right? And root dot data, 50 dot data, correct? Agree with me, everyone?
Yeah.
So from this line, can I say it will be, see, first I have written all the statements, but when I say post order, can I say I'm calling the method again? Yes or no?
Yes, sir.
Yes.
We are calling the same method. Let's again split this method, correct? What is the meaning of 50 dot left?
20.
Yeah.
20.
Now I have to say, can I say 20 not equal to null?
Yes.
And then I should write the same thing, correct? Same code. Post order Okay. Now post order root dot left is nothing but 20 dot left, 20 dot right, 20 dot data. Am I right? Any confusion?
No.
Okay. Now, so can I say from this line, again, I'm calling the same method. The 20 dot left, what is the value?
10.
10. Okay, can I say I have to do again 10 dot 10 not equal to null?
Yes.
I'll paste the same thing, correct? Because I'm calling the same method, so it gets called continuously. Okay. Now here 10 dot left, root dot left is nothing but 10 dot left. That means whenever I'm going inner side, my root will be modified 10 dot right. And here 10 dot data. Now can someone tell me what is the 10 dot left? Can I say from here it will call the same method again?
No.
Will it call? It will call first of all, correct? But it will break, right? So it will go. What is the value of 10 dot left?
Null.
Okay. But whenever you are calling internally, what is the first condition in the Eclipse? A root not equal to null, correct?
Yes, sir.
Now here, first, what is the value? Root, you are passing null. Null not equal to null. Is it true? Condition is false, correct?
Yeah.
If the condition is false, can I say it will be further divided the method or will it stop here?
We'll stop.
So that means,
Stop.
so can I say it will go to this line? Am I right?
Yes.
Yeah.
Because after this if condition, what is the line is there? This one. Now what is the 10 dot right? Null. Again, can I say it will break? Here also, if null not equal to null. Okay. And then it will break, correct? It will false. Now what is the next line it will print? 10 dot data. What is the output, guys?
10.
10, correct? Now can I say it will go down? So this end bracket is done. This end bracket is done. Can I say it will go to post order 20 dot right? What is the value of 20 dot right? That means it is calling the same method. Whenever it is calling the same method, what is the value of 20 dot right?
45.
45. Now can I say it will go inside internally and then it will check 45 not equal to null, correct? Is it true? Is the 45 equal to null or not equal to null? The further method will be split further, correct? Now here 45 dot left, 45 dot right, and 45 dot data. Now, what is the value of 45 dot left?
Null.
Null.
Now, so that means 45 dot left, it will call the method. But can I say, will it break internally? Yes or no? Null
Yes, sir.
not equal to null, correct? It will break. Okay, that means the method will not divide further. Now, can I say what is next line? 45 dot right. What is the value of 45 dot right?
Null.
Null. So it will check if null not equal to null. It will break, correct? And what it will print?
45.
Can I say 45?
40.
Now, according to the logic, what is the one? go towards left side, go towards right side, and then print the data. Now, if you look at the diagram, see, we have went for 10. Do we have any 10 left to 10?
No.
Do we have any right
No.
to 10?
No.
And then we are at the end, go left, right, and then root, correct? So can I say I'm printing the root now? Above I have printed 30, correct? Sorry, 10. Here I did print the 10, right? Done. That's the
Yes.
left side. Now after that, what I'm going towards right side. So does 45 has any left and right?
No.
No, it does not have. But how do I know in the programming? But still I'm checking. See, look at here, 45 dot left, I'm going. It is a null, so I'm coming out of the loop. 45 dot right, it is null, so I'm coming out of the loop. If there is a node, it will go there. So that means I'm, for each node, I'm traversing left, right, and then can I say I'm printing 45?
Yes, sir.
Now, if you take this is a small tree, see, this 20, 10, 45. In this one, can I say I have gone towards left side 10? If I take this tree, what is the post order is telling you? Left, right, and then root, correct? That means first you have to print the left, then right, then root. Now in this tree, can someone tell me, did we print 10? If I take this
Yes.
smaller tree, yeah, left side 10 we have printed, right? Did we print the right side 45?
Yes, yes.
What is the leftover in this tree?
Root
Root, what is the value?
20.
Now, can I say after this line of statement, you can see system.out.println 20.data. What is the value 20.data?
20.
Can I say it will print 20?
Yes, sir.
Now, if now you're done with this small tree, correct? Now let us take this one big. So 50, 20, 10 to 45. Now can I say I have done what is the left side of 50?
20.
It is not only 20, 20 followed by this subtree, correct? Now can I say I have completed this subtree left side?
Yes, yes.
Did I complete the right? See, what is the post order is telling you? Left, right, and then root. Did I complete the right side?
No.
No, I have to go to right side. Correct. See, do you
Yes.
do you look at here? Same thing. So now 50 dot right means what?
70.
Okay. Can I say I have to write the same logic again?
Yeah. Yes.
Yeah, 50 dot left. Sorry. 50 dot right is 70. 70 dot left. Do you have any element? 70 dot right and then 70 dot data. Correct. Now, what is the value of 70 dot right?
Null.
1 not.
70 dot, sorry, left, my mistake, sorry. 70 dot left
Null.
is null, correct?
Null.
Can I say it will break if null not equal to null? It will false, right? Can I say it will go this line? 70 dot right, what is the value?
1 not 1.
Again, I need to have the same lines of code, correct? Because I'm calling the same method. Now, 70 dot right means what? 101. What is the 101 dot left?
Null.
101 dot right?
Null.
No, so both are null means can I say it will divide and then can I say it will false if null not equal to null, correct?
Yeah.
It will come out of the loop. Okay. Here also it will come out of the loop. If null not equal to null not equal to null. Can I say it will be false? Yes. Now 1.1 print data, what it will print?
101.
101. Now can I say 70 left is not there, correct? If it is there, I would have printed. It is not there. 70 right is there. Done, I printed. So for 70 left is done, right is done. What is the left? What should I print now?
70.
70. See, do you see that statement? Yes. Now, what is the left side of 50?
20.
20.
10.
And that means this is a subtree, correct?
Yes. Yes.
Now, what is the right side of 50?
70.
And
And
101. This is another subtree. Now, can I say I printed this left and right?
Yes. Yes.
What is left over?
Root 50.
Yeah. So if you look at the statement, what is left over here? 50, correct? Can I say
50.
my output will be 50?
Yes.
So this is a post order, correct? So now whenever you debug, it will be in a different manner, correct? I'll share it with you guys, but just look at. I hope everyone understood.
Yes, sir. Yes, sir.
So can you guys try pre-order? I have explained in order, post order. I am requesting you guys to try the pre-order. Will it work?
Yeah.
I see response from only one. What about others?
Okay, sir.
You understood, right? How the way the code is executing?
Yes, sir.
Yes.
If you debug, will you be able to understand? Suddenly it will come out of the loop and then it will go there. So you have to write, okay? So please, guys, if you write, you'll get some questions so that we can answer it, okay? So write the pre-order. It's already there in the homework. Now today we are going to look at so we completed the tree, binary search tree, insertion, and then in order, pre-order, post-order. Next we are going to see tree map. So this is most frequently asked question. So what is a tree map? Now, if I want to create a custom tree map, how can I do? So we already created a tree map, custom tree map. So let me show you guys. Tree map, IMPL, something. Okay. Now here in Java, we don't have a class called tree, predefined class called tree, but we have something called tree. So tree is also extending from map interface. String integer something, I'm taking m equal to new tree map. Okay. Now, so what is the method in map I can add the data? Put method. Yeah. Now you guys remember in I told in hash map there is one problem, correct?
Yes.
So how does the put method works in a hash map? What do we do inside put method first?
We calculate the hash
code.
Okay. Then
the
after calculating the hash code,
divided
Compares
by
the equals method.
1%, please. Go ahead, Satish.
Yeah, hash code and equals method contracts are both to check.
Okay. No, that is not the answer. First, we'll calculate the hash code. After calculating the hash code, what do we do?
It will find out which index it has to be. The mod operator, it will decide and choose the bucket and
Yeah, based on the hash code, it will
yeah.
perform left shift operation by 16 and it will
Correct,
identify
correct,
the
yeah.
index. Okay.
Yeah,
Once the
by
index
base
is created, what happens?
it will store it in a linked list or something. I mean, list of thing next something it is stored.
First
Node.
of all, will it go to a, so it will create a node object first.
Correct.
So
Node
it
Yeah,
will,
object. Correct.
for the
yeah,
first
yeah.
time, it will not have a linked list concept. First, it will create a node object. What does the node object will contain?
Data and the node reference to the next.
It will contain the hash
Ha-
code
Hash code, key value,
and the
and
node
next.
of next. Yeah,
Mhm.
good. So hash code, key, value, key object, value object, hash code, and the address of next node. Now, so here, can I say if I am entering 65, can I say what is the hash code of A?
65, right?
65.
Now, which index it will go?
Fourth index.
65 divided by
65 divided by 16 something,
16.
approximately fourth index. In the fourth index, can I say node object will be created? Node 65 comma A comma 1 comma null, correct?
Yes.
Now, so can I say here? Here also, what is the value index? Equal to 66. Hash code of B is 66 divided by 4. What is the value? 4 only. Now,
4 only.
but whenever it is same, can I say it will call the equal sign hash code contract? Correct? So what is the
Yes.
equal sign hash code is returning 66. That means can I say these two are different objects? Correct? If the see, what is the hash code of A? 65. What is the hash code of B? 66. Is it same?
No.
If it is same, then it will go to the equals method. If both are same, then only it will replace the value. But in this scenario, hash code is different. So what internally it will do? It will create a node. Correct? Like this. 66 comma B comma 10 comma null. And first node will contain the address of B node. Correct? Here it will apply. We know how to attach this address also. Correct? Temp equal to temp.next. Temp.next equal to n. Correct? Agree with me, everyone?
Yes, sir.
Now, so here, whenever I enter the same thing, A comma 12, what happens?
Once again, hash code is
Yeah, again, what is the hash code?
65.
Okay. And divided by 4, 16, it will give you the index 4. But
Oh.
is it a different object? Same, what? Yeah, go ahead, sorry.
Same one.
Okay, how does it know?
Equals method hash code will check.
Yeah,
Hash
hash code
code the
method
same.
is already hash code is there. Currently, one element is having 65, and your hash code is also 65. If the hash code is same, then it will go to the equals method, and then A
Equals
dot
method.
equals A. Both are same. Hash code method checks the whether you are referring to the same memory location or not, and equals method will check the content is same or not. Correct? Now, see both are same. Then what happens? Can I say this value will be written? 65A, 1 was there. Can I say 1 will be replaced with 12?
Yes.
Yeah. So the C also can happen. Now, I assume that I am trying to give 1000 nodes. Out of the 1000 nodes, around 700 nodes are getting the index as 4. What is the problem is called?
Performance issue.
Performance issue, correct? In order to overcome the performance issue, what did I say?
Binary tree.
We go for B
setting.
tree. B tree or binary tree, something, correct? Now, so can I say now we are in the tree map? So this is what can I say? This is the entire concept that we learned in the hash map. I hope you guys
Hash map.
remember everyone, right?
Yes.
Yeah.
Yes, sir.
Now, when it comes to a tree map, so in just now we have learned in priority queue, what happens, guys? What is the difference between other queues and priority queue?
Priority queue is ordered. Sorted.
How can you say that it's order? What sorted order? Is it ascending, descending? How? It will define.
Natural sorter ascending.
Okay. I mean, internally, what it uses? It uses a comparator, correct? If you do not pass any comparator, whatever the generics is there, it will go and look at the generics, whether it is implementing a comparable interface or not. correct? So, but do I have that kind of a flexibility in a linked blocking queue or some other queues?
No.
Array queue, no. Only the priority queue internally uses a comparator. Similarly, let's look at tree map. In the tree map, what do you see one statement called comparator equal to null? That means, so here our hash map is not ordered, but the tree map is ordered. Now, see here, let me add Z, A, B, small a. Now, if I try to print, if I add these elements into a hash map, normal hash map, will it give you the sorted order?
No.
No. But let us look at sysout M. Let's run the program. See, can I say is my output is sorted by keys, correct?
Yes.
What is the ASCII value of A? 65, 66, something 91, and then this is around 92 or 93, something. That means, did I see, even if you run 10 times, you will get the same output because, so we can say that tree map is, what is the difference between a hash map and tree map? Hash map is not ordered. Tree map is ordered. When I say tree map is ordered, in the map, we have two objects, key object and value object. By which element it is getting ordered?
Keys.
Key, correct?
Key.
So by default, tree map follows the insertion, ascending order and key object. Okay. Now, how it is possible? Now, if you look at here, internally, say, whenever I'm calling this one, am I passing any here? Am I passing any object here? Or am I calling the default constructor?
Calling default constructor.
So default constructor. So what if you look at here, their comparator equal to null. That means if you are or there is another tree map constructor. See. So that means, can I say here, if I do not pass anything, by default, what happens? What is the generics key for key? Here in this program, what is the generics of my key object?
String.
String. Can I say string class is implementing a comparable interface? Yes.
Yes, sir.
Now,
Yes.
can I say it will go to compare to method? Correct. So let's keep a breakpoint and debug it so that it will come here. So that means what is happening internally? If you are not passing anything, what it will check, whatever the generics that you have mentioned, it should implement a comparable interface and it will go there and it will execute. Correct. So why the tree map is ordered? If you are using a wrapper classes, the tree map will sort the data by ascending order of a key. Okay. Why it is happening? Because internally it uses a comparator. If you are not passing any comparator, whatever the generics that you have passed for key, it will go to the generics. Now I want to reverse the order. I want to sort this hash map in a reverse of order of a key. Sorry. Write a program to sort the tree map in reverse order of key. I hope you understand the question. So, okay, now the question is immediately, can I go and change the code of a string class comparable interface?
No, we can't.
Then what should I do?
We should write our
own comparator, correct? Right.
Yes.
Now, if I do not pass anything, can I say it will call you it will call the default, so it will check, are you passing anything? No. Then it will go to string class comparable interface, compare to method. Now, instead that what I want reverse order. Can I say I will write my own comparator? How can I write own comparator? I can create a class, implement an interface, and then create an object here. Or can I say I can write anonymous in a class? Yes or no? Guys, are you following me?
Yes, sir.
Yes,
Yeah.
sir.
Here, what is the generics I should keep? String, because my generics here is string, correct? Yeah. Now add return statement. What should I do? Return O1, O2 dot,
Value.
O2 dot equals ignore case. Sorry, it's a 02 I mentioned, sorry. O2 dot, O2 dot compare to, yeah, compare to dot O1. Okay. Now let us run the program and see what. Now, will it go to the string class compare to method?
No.
Because I have passed a comparator. That means it has, see, if you, whenever you are doing this one, can I say, am I calling the default constructor or single argument constructor?
Singular.
So that means from here, look at here, it is going to this one. So they are doing this dot comparator equal to comparator. That means it will call your comparator. Now let us execute. See, is it doing the reverse order now? Yes or no?
Yes, sir.
Yeah.
Yes,
So
sir.
this is the simplest thing. Now, if you want to sort the, see, this is a by default. What is the order that tree map follows? By default,
Ascending.
ascending order
Ascending.
of what object?
Key object.
Key object. Okay. Does the hash map follow any order?
No.
Now, in order to make the hash map ordered by keys, what should I do? Write a program to sort the hash map by keys. I'm talking about a hash map.
Yeah, so you need to use collection.sort, but that will use the list only. You need to convert that list to a set and then back to list of generics and do this.
That means first, my intention, if it is a hash map, my intention is to convert to a set as a collection.sort method. That means it takes list only. So first
Correct.
convert the hash map into a set. How can I do? By calling the entry set method.
Entry set, and then you
And
have
then,
to
yeah,
collections linked. I mean, the linked list you have to pass, and constructor you have to get as a list of generics.
yeah. And then that means it will give you map.entry object, right? And then you pass it to a linked list constructor, you will get a list object. And then you can pass a comparator and you can do whatever you want. Okay. So that is for hash map by key or hash map by value sorting. In the comparator, whatever you take it as, if you put o1.get key, it will do. If you put o1.get value, it will do based on whatever you want. Now, one of the simple solution is, let us keep map string integer m1 equal to new hash map. Okay. Now m1 dot put you can add, if you are adding a generic, then you have to implement the comparable interface. If it is a what you call tree map, if not, you will get a runtime error, correct?
Yeah.
Okay. Now, can someone tell me, if I print hash map, this one m1, will I get an order?
No.
It will give you, see, first A11 is coming, correct? Now, if I run the program again, it might not give you the same order, correct? If you run 100 times, it's a different order you will get, correct? See, earlier R13 was coming here. Now, we already know one way of doing sorting a hash map by keys is converting from the map, getting a set, converting the set into a list, and then calling the collection.sort method, and then passing a comparator. Now, what is the other way is, in the tree map, do you see one more constructor? So what does this constructor is taking map extends. So it is taking a map object, correct?
Yeah.
So map is a interface. Hash map is a child class. So can I pass the hash map object here?
Yeah.
Yeah. So let's look at here. So now what I will do is M2 equal to new tree map. And then can I pass M1 here? Why am I not getting a compilation error? Because I am calling a different constructor, which takes a map object. Correct? Map is a parent, hash map is a child. Can I pass?
Yes.
Now, if I by default, so that means if I put, but you know that concept that by default, what does a tree map will do? What is the order?
Ascending order.
Ascending order by keys.
By
Correct?
the generics. By
Key
the
object.
generics.
Yeah, key object, right? So like, can I print M2 now?
Yeah.
I have added. So if I do this, can I say my hash map is ordered now? See, look at here. Is it ordered?
Yeah. Yeah.
So this is another way to see. But can you do key or key value ordered or by key only ordered?
You
By
can do
the
only,
key.
we have the constructor only for map, right? So
No.
Mm.
See, my question is, I have given a hash map. I'm asking you to write a program to sort the hash map by keys. So one answer is you already know. Okay.
Yeah.
The other answer is if you are passing the hash map object to the tree map constructor, then it is sorting. But what is the order it is sorting? Is it sorting by
Key.
keys or is it sorting by
key.
value?
It is sorting by
Key.
key.
Because tree map by default follows sorting of a key, correct? Yeah.
You have
But if
to,
yeah, go ahead.
maybe there might be another constructor which will have the
No,
comparator
there is
that we
no.
can.
Yeah, that
Okay.
is what. So then which one we have already seen, right? See, there is a tree map constructor which takes a comparator object. Here, whatever you pass, it will do like that, correct?
Okay.
See, this is a different one. So
Okay.
whenever you go some interviews, whenever you answer it, they will ask you, write a program to sort the hash map by keys. Okay. Then some people, what they will do, they'll create a hash map and they'll create, pass this hash map object to a tree map. And then they'll say it is ordered. But immediately they'll ask a question, do it without tree map. Without tree map means we have to go to the answer of set, get the set. By
Yeah, the old way.
entry set. Yeah. Entry set, linked list object, and then collection.sort method. If in that they're asking you to sort by value, in the comparator you can do. If they are giving you tree map, by default tree map follows the order by
Key.
key, and it's a natural sorting order. Don't tell that it's an ascending order, because whenever alphabets are given or string is given, can you say that it's an ascending order in a string? No, right? Generally, it will be converted into ASCII, correct? Ascending or descending can be hold for numbers only. Am I right?
Yeah.
So you have to call it as a natural sorting order. So tree map follows the natural sorting order by key object. What is a natural sorting order? If the generics is an integer, if your key object is an integer or double or float, then what is a natural sorting order? It's an ascending order. If it's a string object, what is the natural sorting order? Based on the ASCII value. Correct?
Yeah.
Okay. Yeah. Now let's go back to the discussion that we have learned. So whenever 1000 nodes are there, at one index for 700 nodes are there, then it's a performance issue. In order to overcome that, we go for a binary tree. Now in the binary tree, how the performance will be reduced? So can I say this performance issue is coming while retrieving the object only, or while saving the object? Which one? The one who answered the question. Yeah, while retrieving, correct? See here, now whenever you're doing, so this is at index 4, there are 1000 objects like this. Now, if I want to get this object, then first what I will do, I'll go to this. My key object is A, and its hash code is 65, and the value is 123. First, I will compare this key hash code. Is it equal to 65? No. Then I'll go here. 60. Is it equal to 65? No. Like that, can I say I have to do the compare 699 comparisons? And then I can retrieve this value, correct?
Yep.
So this is a performance issue that we have learned in the binary tree. Now, you already know, sorry, performance issue in the hash map.
Not binary tree, hash map. Yeah.
Yeah. In order to overcome that, I say that we go for a binary tree or binary search tree, whatever. Some tree concept will go. Now you guys know now what is a tree, what is a binary search tree. So what is a BST? Can someone tell me?
It has left and right thing, and left side will be less and right side will be
So that
more
means
than
whatever
that.
here you have some value called X. Okay. Less than X will go towards left side, greater than X will go towards right side, correct?
Yeah.
Now, again, here you have A. Less than A towards go left side of A, greater than A towards go right side of A, correct?
Yep.
For example, let us take this is a 100, this is 65 or 70, 65, 72, 101 or 110, 101, 120. Okay. Now, assume that now you want to find out this one. So assume that instead of a linked list approach, you are from Java 1.8, they are using binary tree approach. Now let us see whether the performance issue will be resolved or not. So where do you start your logic if it is a tree?
Root.
Sorry. So can I say my root is 100?
Yeah.
Okay. Now what is my hash code? 65. They assume that this is a hash code. Okay. 65 is lesser than 100.
Yeah.
Yes.
So where should I go?
Left side.
What's left side? So can I say
Left
I'm not comparing with these three, correct? Can I say half of the searches are gone, correct? Yes. Now next I will compare with 70. 65 less than 70. Is it true?
Yeah.
So can I say this side there might be these many nodes, correct? Like this. There might be many nodes. Can I say I can ignore all these nodes if this is true, correct? So that means, am I reducing the number of searches?
Yeah, you are able to achieve it in two
Yes, two
blocks.
iterations only, correct?
Yeah.
So now let us see. So that's the beauty of a tree map. Now let us see whether it is following the same. See, I told something binary search tree, but how can I prove? Can I say internally inside the put method, we have to see how they are following, correct? Let us go put method. See, this is a.
So this implementation is from 1.8 onwards only. This.
Yes. Yes. Let us go to the tree map class. We know tree map, right? So tree map method will go to the put method. So do you guys see put method? They are calling put the key value true. Something. Let's go here. Okay. Do you guys see first they are calling a root object? What is a root? It's an entry. Entry is nothing but it's a class similar to the employee class, which holding key and value, correct? Now, if you look at here, internally it uses a comparator, correct? See, comparator means it has a compare to method. Am I right? So now here, if you look at here, guys, see whatever the value that you are getting from a comparator, see they are taking it as int value, correct? Nothing but something like a hash code or something. Okay. If it is less than 0, where they are going?
Left.
If it is greater than 0, where they are going?
Right.
So that means, are we following the similar thing?
Yeah.
So that means,
so if
see,
I run the program with the if I run the program with the 1.6 or 1.7, you will not see this implementation, right? It will be a
so you will not be able to identify whether it's a 1.6 or 1.8. What you have to do, go to the Open Java, okay, Open JDK, and then try. See, currently you cannot. The minimum version that you can download Java is 1.8. Okay.
Correct.
If you go to the Oracle website, so in order to look at it, what you have to do is you have to go to the Open JDK and try downloading 1.7. And after downloading, what you do is tree map will be like this only, but you have to go to the hash map class. Inside the hash map, if you look at the put method, they are calling put value. If you look at here, they're following tree instance of tree node. If you look at the code
Yes, sir.
1.8, it is something similar to the linked list or node kind of a thing. It is not
Okay,
a
okay,
normal tree node. It's not a tree node. It's a normal node.
okay.
Okay. Now let's go back to the tree map.class. Look at here. Can I say this code is similar to my, what is my binary search tree? Correct?
Mhm.
So here, this CMP is nothing but some hexadecimal, some integer number. This is coming from your comparator, correct? See, whatever the comparator that you are implementing, based on that comparator, see, look at here, what you are implementing. Here, whenever I am writing, see, I am return O2. So what am I returning from compare method? Int value, correct? Yes or no?
Yeah.
If you look at the string class compare method, all the compare method will return int value. Now, based on that int value, what they are doing internally, if it is less than 0, towards left side, they are going. If it is greater than 0, towards right side. So in this way, whenever you are coming back again, same comparator code will execute, correct? And then it will know whether to go towards the left side or right side. That's how the performance issue is resolved. Hope you understand, guys.
Yeah.
Any questions? So that means we already learned a tree map without knowing a tree map, correct? See, we have implemented, can I say that we have implemented a binary search tree? If you look at here, in the add method, did we implement the binary search tree? How did we implement? We implemented based on the root, correct? Anything lesser than root, I'm going towards left side. But instead of root, can I call the compare method and then take the, instead of root value, can I replace this with a comparator logic? Am I right? Here, instead of calling tempo.data, can I call the comparator.compare2 method? Yes, it will return an int object. That integer, I can store it here. So that is nothing but an implementation of a tree map. Any questions? Is it understood, guys? Shall I repeat anything, Satish?
No, we are very much understood.
Yeah, thanks. So I'm just asking others also, right? It is not only Satish. If I see Bharti is traveling, Sachin, Anil, Sunil Reddy, Rashid, Shiva. I hope you understand, guys.
Yes, sir.
Yes, sir.
Okay. Now, internal data structure for a hash set. Hash map. So can I say we have a tree set also, correct? So what is the internal data structure for a tree set? Let's go. Add method, correct? How do I know? Go to the tree set and then look at the add method. So can I say again, what is the M? What is the M? Let's look at here. See here, navigable map or nothing, but it's a tree map only. Let me show you. M dot put. Where it is going? From here, it will go to the tree class map method. See, a tree class map method means it's a, so the internal implementation for a tree set is a map. What map? It's a tree map only. Why it is showing a navigable map means, look at here. Navigable map. Okay, let me show you. The parent class for tree map is navigable map only. That's the reason. When you are using a parent, you can use a child too. Let me show you. What is a parent for a tree map? Look at here. It's a it can be abstract map, which is a class, and parent, can I say it's a navigable map? So in the tree set, you are using a navigable map. That means, can I say you are using a parent reference? Yes or no?
Yeah.
Yeah. So that means the internal implementation of a tree set is tree map. The internal implementation of a hash set is hash map. Why don't we have a get method in the hash map? Sorry, hash set. I repeat my question. Why don't we have the get method in a hash set?
So the value is shared.
Every time it is written object of object as present.
Yeah, because the internal data structure for a hash set is hash map. Whenever you are adding a data to a hash set, we are using a add method. Using add method, I am passing only one object. That object is considered as a key, and the value is object of object class. Even if I am trying to use a get method, by passing the key, I'll get an object of object class. For all, whatever you pass the key, you'll get only one object, correct? So there is nothing new. Hence, we don't have that one. Similarly, if you look at here, can I say same thing is happening? In the tree set, whenever I call the put method, what is the object? I will pass some Karthik, Ajay, something. Whatever the object I pass, that will be taken as a key. And what is the value? Present. Present means object of object class.
Object of object class.
Can I say logic is same?
Yes, sir.
Yeah. So can I say we don't have a get method also in tree set? Look at here. See, if I try add method, it is showing. But if I try get, am I able to see any method? No.
No.
So this is the reason why don't we have the get method. Remaining all are same. Any questions? So there is one topic that is pending of queue implementation using stack. We have studied about stack implementation using queue, but queue implementation using stack is pending. I'll explain that tomorrow. And apart from that, we also start looking at the interview questions. Okay. So from Wednesday onwards, we are starting with advanced data structure concepts. So whoever, I hope many of you have joined for collections. So collections will be ending by tomorrow. And from Wednesday onwards, advanced data structure concepts will start. You can join the demo class. And if you are interested for the advanced data structure topic, you can pay the remaining fee and you can continue attending the classes. And I'll continue like in the advanced data structure classes, whatever sorting, searching, graph, dynamic programming, I'll explain the same way what I explained in the collections. Then that means I will write a program. If it is a merge sort, I will write a program. I'll explain first the concept, then algorithm, then convert the algorithm into a programming. So the way of teaching would be the same. No, it will not be differing much. Okay. But if you are interested, you can join the demo. And if you think that it is needed for you, and then only you can pay the amount and you can enroll the classes. So tomorrow we are going to implement queue using a stack. And then we are going to look at the collection interview questions. After that, this class will be over. And then we'll start with the advanced data structure topics. Any questions, guys? Does anyone has any questions? Feel free to ask me, guys. Even if time does not permit tomorrow, don't worry, we can have a class over the weekend, next week or something, and then I can clear your doubts. Okay. Don't think that the time is a constraint. No worries. Even during the demo classes or weekend class, I can arrange a weekend class and I can clear your doubts. Okay. And I have shared the poster of a advanced data structure class in the group. Did you guys get that?
Yeah.
Yes, sir. Yeah, you can join those classes, demo classes. See, whether you're enrolling for that course doesn't matter, but join the demo classes, guys. I'm going to explain the time complexity, space complexity, some bubble sort algorithm or selection sort algorithm. At least you can learn that. Okay. See, I'm not against not to enroll or enroll. No. First, you listen and then only decide it. Okay. Yeah. So just so tomorrow we are going to discuss queue using a stack implementation, and then tomorrow we'll get started with the interview questions. So whatever you have learned till so far, I'll ask you the questions in that. Please be prepared and then come back. Okay. And the work for day is write a pre-order for the given tree. I've written a in order, post order. You guys have to write pre-order. Okay. So if no question, that's all for today, guys. How do you feel, guys? Have you learned something new? Does this course improve your tech coding skills, etc.?
Yeah, absolutely.
Yes, sir. Yes, sir.
I mean, like before joining the course, you were expecting something. Some people are asking, will I be able to? I'm very bad at coding, but am I able to improve something like that? But hope you see the difference from yourself, right?
Yes, sir.
Yeah. Only thing you need to practice, guys. And in future also, if you get any doubts, you can ask me through the WhatsApp. The WhatsApp group will be there. I may not be responding immediately, but surely I'll respond. Okay. And someone asked about the code. I will share the code maybe after the another. I have a class at multi-threading. After that, I will share the code. Okay.
Thank you.
Yeah. Thank you, guys. Thanks for joining. Have a nice day.
Sir.